Hi everyone, this is lesson 6.5 for Algebra 2A, and we're continuing our discussion of logarithms by looking at some properties of logs. You did cover all of these last year, so you have seen this before, and I will tell you that these first few properties that we're talking about are really pretty closely related to the properties of exponents that we talked about just a few lessons ago. So if you kind of compare these to those, I think it'll start to clear up why these work the way they do, because remember, logs are really just exponents. It's just an expression for the exponent in a function. So, for example, when I say log base b of 1, really what I'm saying is any log of 1, no matter what the base is, what will that always be equal to? Well, anything to the power of 0 equals 1, right? So the log of 1 is always 0, no matter what the base is. Log of 1 is always 0. Okay, these next few are a little more based on operations here. So if you take the log of two numbers that are multiplied together, the log of a product, and you want to separate that, it doesn't separate like the distributive property. It's not going to be like log of x times log of y. Because we're dealing with this like the world of exponents, I want you to think back to when we talked about powers. And when you multiplied two powers together, you added the exponents, right? And so what that translates into is if you do want to separate this and write it as two separate logs, you can write it as log of 1 plus the log of another. Okay, so multiplication becomes addition in the land of logs, because if you think about it, each one of these represents an exponent. Okay, and so when you're multiplying powers together, you add the exponents together. And I want to make sure we understand that this goes both ways, that sometimes I'm going to give you something like this and you're going to have to separate it. Probably even more often, I'm going to give you an expression that looks like this and expect you to be able to put it back together again. Okay, along those same lines, if you believed me on this with the addition, you're going to believe me here when I tell you that division means you're going to subtract the logs. So this would become like log base b of x minus log base b of y. And I tell you that you're going to believe me because remember that when you divide with powers, you subtract the exponents. And then this last one is a property of powers. And if you've got a power on something that you're trying to take a logarithm of, you can rewrite that expression by putting that exponent in front as a multiplier. And again, that has to do with the fact that when you raise a power to a power, you're multiplying things together. So we can rewrite this as p times log base b of x. And there's going to be some times when you're going to want to write it like this, and there's going to be some times that you want to write it like this. The idea here is to be flexible, to know that these two things are equivalent to each other. Okay, so some more simplify without a calculator stuff here. So this first one, log base 6 of 2. I don't have any way to figure that out without a calculator, because really what I'm asking myself there is 6 to what power makes 2? I have no idea. That's going to be some crazy decimal. But the fact that I'm combining it with a log of 3 with addition means that I can put these two things together using multiplication. So I can say log base 6 of 2 times 3, which is really log base 6 of 6. Okay, that's looking a lot better, right? Because now what I'm asking is 6 to what power makes 6, and that's really easy. The answer to that is just 1. Similarly, with the next one, I see subtraction, right? So that means I can combine them with division. So log base 5 of, and I want to point out it's not log of 1 divided by log of the other. It's log of the two numbers being divided. So 200 divided by 8. Okay. That might be kind of rough, but I think you can do 200 divided by 8 in your head. You could always divide it by 4 and then cut that in half. So 200 divided by 4 would be 50, and then 50 divided by 2 would be 25. So this is really log base 5 of 25. And then remember the question I'm really asking is 5 to what power makes 25? That would be 2. Okay. Next one's got a lot of stuff going on. So I see subtraction, I see addition, and I see this 1/2 floating out here. So before I do anything, I'm going to put that 1/2 back up here as a power just so I can get it out of the way. So that's 400 to the 1/2 power. So now if I want to combine these three things, this is what that's going to look like. It's going to be one big log. This will be division, 85 divided by 17 multiplied by 400 to the 1/2 power. That's really asking you the square root of 400, which is 20. Okay. 85 divided by 17, that is kind of a rough one. I would start thinking about, what do you know that goes into 85? But 85 divided by 17 is 5. Okay. 5 times 17 would bring you to 85 here. So this is log of 5 times 20, which again is really just log of 100. Now notice there's no base on this one. I haven't been carrying a base around with me here. That means that the base is really 10. So what I'm asking is 10 to what power makes 100? And the answer would just be 2. Okay, let's keep going here. So this next one says, rewrite each of the following without a logarithm. Okay, be careful here because I see people all the time want to just come through and start crossing out the logs, like you're canceling it out, right? You can't divide by a logarithm. You can't cancel out the logarithms by just dividing by log all the way through. That's like dividing by a plus sign, okay? You can't do that. But what we can do is get it to the point where we've got like log of something equals log of something else. And if we can get it written that way, then I can conclude that the two somethings are equal to each other. Okay? So this one is really close to that. The only thing I really need to do is move that 1/3 out of the way. So I'm going to take this 1/3 and put it up here as an exponent. Whoops, that should say 1/3, not 13. And then I can say x must equal a to the 1/3 power. That's not me dividing by the natural log. By the way, that's a natural log, okay? That's not me dividing by natural log. That's me just saying that if the log of this is equal to the log of that, then the this and the that have to be equal to each other, okay? So I could then say x must equal a to the 1/3 power. For this one, I'm going to focus on simplifying this side. So I'm going to take this 4 and put it up here as an exponent. And then I see subtraction, so I'm going to turn this into log of a division problem, a divided by b to the 4th. And now that I'm at the point where I can say log of this equals log of that, now I know that this has to equal that. So my answer would be x equals a over b to the 4th power. Okay, this next example, these are tricky. And really the math in them is not hard, but knowing how to start them can be difficult. So you're given these two different logarithms. You're given log of 6 and log of 4, which means for each of these expressions, I'm going to want to somehow write it as something involving a 6 and a 4. So for example, log base b of 24, I'm going to rewrite that 24 as 6 times 4. Okay, and yes, it would be base b. Okay. The reason I want to do that is I know the rule for this, right? If this is written as multiplication, then I'm allowed to call this log base b of 6 plus log base b of 4. I can separate that using addition, okay? Well, I know log base b of 6. It's this number, so I can say this is now 1.631, and this one is 1, whoops, sorry, I didn't mean to cross that off. this is 1.262. And so really all I'm doing is adding these two decimals together. And that's going to give me, oh, let's see if I can do this, 2.893. I hope I got that right. Yeah, that should be right. So this here would be your answer. So let's try that with the 16. Can we think of a way to write 16 using a combination of 6s and 4s? And by the way, I should point out, you don't have to use 6 and 4. If you can do it with just one number, that's okay. So log base b of 16 is really log base b of 4 squared. Okay, you can use exponents. Okay, exponents are okay. Because remember, what that's going to allow me to do is move this 2 down in front. So I can now call this 2 times log base b of 4. And again, I know log base b of 4. It's 1.262. So what I'm really doing now is 2 times 1.262, which is going to give me, oh boy, I might screw this up. Yeah. I would hate to screw up on a video and have it captured for all time. Oh, I would have had it. Okay, 2.524. That's what that's equal to. Okay. The other way you could have thought about this one, by the way, is you could have thought of this. I'm going to just jot this down here. You could have thought of it as log base b of 4 times 4. Right, instead of calling it 4 squared, which means you would do log base b of 4 plus log base b of 4. And then really you would just be taking this decimal and adding it together twice. You'd do 1.262 plus 1.262. Going to be the same thing as multiplying by 2. So same idea, it just depends on how you want to think about it. Okay. That third one is tough. If we were in class together, I would probably challenge you and let you think about it for a minute and see if you come up with a way to make a 9 using 6s and 4s. Okay, I'm just going to show it to you so you don't have to, sit through a moment of silence here on the video. But if you take 6 and square it, you get 36, and then 36 divided by 4 is 9. Okay, we had to get a little creative on that one. That one was a tough one and probably harder than most of the ones you're going to see, although I may throw some curveballs at you like that from time to time. Okay, got to get a little creative here. But 36 divided by 4 makes 9. So if I separate this out, this is now log base b of 6 squared minus log base b of 4. Oops, that should be a big 4. I'm going to put this 2 down here in front. And then I'm going to take log base b of 6 and replace it with 1.631 minus log base b of 4, which is 1.262. And then this is the calculation I'm doing. 2 times this minus 1 of this. So 2 times 1.631 minus 1.262 leaves me with, oh, that's just equal to 2. Okay. Okay, those are some tough problems. You got to be a little bit creative with those, but I think they're good math. You should have a homework assignment for this section, section 6.3. And as always, if you have questions when you come back to class, we'll make sure to go over them. All right, have a great day.